Hashing is a fundamental computer science concept that uses a mathematical algorithm called a hash function to map data of arbitrary size, the input, to a fixed size value, the output. This output is known as the hash value, hash code, digest, or simply hash. Core hashing concepts. Hash function. A hash function is a deterministic function that takes an input and returns a fixed size hash value. Input, key, any block of data, such as a file, a password, or a string. Output, hash value or digest, a fixed length string of bits or characters, regardless of the input size. Example, a file of 1 kilobyte or 1 gigabyte will both result in a 256-bit hash using SHA 256. Properties of a good hash function. Ideal hash functions, especially cryptographic hash functions used for security, must exhibit several key properties. Deterministic, the same input must always produce the same output. Uniformity, the hash function should distribute the inputs as evenly as possible across the range of possible hash values to minimize collisions. Pre-image resistance, one way. It must be computationally infeasible to reverse the process, to find the original input given only the hash value. Second, pre-image resistance. It must be computationally infeasible to find a different input that produces the same hash value as a given input. Collision resistance. It must be computationally infeasible to find any two different inputs that produce the same hash value. Hashing applications. Hashing is used in various applications, which dictates the type of hash function required: simple, non-cryptographic, or cryptographic. 1. Data integrity and verification. The hash acts as a digital fingerprint for data. If you download a large file, you can calculate its hash. If the calculated hash matches the hash provided by the source, you can be sure the file was transmitted without error or tampering. Even a single bit change in the file would result in a completely different hash. 2. Password storage. Instead of storing user passwords in a database, which creates a massive security risk if breached, systems store a salted hash of the password. The salt is a unique, random string is added to the password before hashing. This prevents attackers from using pre-computed rainbow tables, lists of hashes, and corresponding passwords. 3. Hash tables. This is a primary application in data structures for efficient lookup, insertion, and deletion of data. The hash value is used to calculate the specific index or bucket in an array where the data is stored. The benefit of this is it allows operations to be performed in O1 average time complexity. 4. Digital signatures. Hashing is used to create a short, fixed-length digest of a message or document. This digest is then encrypted using the sender's private key to create the digital signature.